everybody, my name is Miss Walls. I teach at Woodville, Tompkins. I teach honors chemistry and AP chemistry. I'm going to be teaching you guys a fun lesson about making ice cream in a bag, and it's for anybody and everybody who wants to do this, even if you are in 5th grade, 2nd grade, or a high school senior. This is something fun to do because the weather's about to start getting hot, and you want a cool, tasty treat that's, cheap, free, right? So let's go ahead and get started and talk about this. We have this lovely slideshow for you to kind of talk about the main ideas that we're looking at so we can all learn a little bit about chemistry. Even though it's kind of boring, we got to make it fun, right? All right, so the first thing we're going to talk about is the law of conservation of energy and mass. This basically states that anything that we put into a system could be a beaker, it could be our bodies, it could be our car. A system is just an enclosed space that we're looking at what's going on for science, whether it's chemistry or biology or physics. What we put into this system is what we get out. The energy that we put in is going to be transformed. We eat food, we get energy. You know what happens afterwards. You put gas in your car. You're allowed to drive as far as that gas tank can be full. Once it hits empty, car can't go anymore. Another thing we got to think about is basically we can't make things appear out of nowhere. So we are not magicians. We're not wizards. We can't make things just simply disappear. No Harry Houdini acts here. When we're making this ice cream, what we put in is exactly what we get out. We're not going to be losing any ice cream halfway through unless you start eating the product before it's done, and I can't stop you from doing that. So if you want to, go for it. I hope you enjoy it. All right? Next thing we're going to talk about is states of matter. We all know about states of matter. We've seen them. They're all around us at all times. We've got gases and liquids and solids. And for those of you who don't know, we also have plasma. That would be something like lightning or the surface of the sun, things that we don't see. You may have heard the terminology plasma, which comes from our blood. That's different, not the same idea, but same words. Sometimes words have double meanings. We're going to be focusing on liquids and solids today. If your ice cream is in gas form, you probably shouldn't eat it. Okay, states of matter. All states of matter have a special term or terminology that's associated with it. They all have their own definitions. We're thinking of terminologies like freezing and boiling and melting, and we know what those words mean. When we say freezing, we're talking about something going from a liquid to a solid. If we're talking about melting, it's going from a solid to a liquid. We see this every day in the summer when we're having ice cream. It starts to melt. Oh no, you gotta eat that pretty quickly. So looking at definitions here, we've got liquid. It's a state of matter that has a defined volume but no defined shape. And you're kind of probably sitting there going, what does she mean by shape? Think about a can of soda. We got a can of soda. It's got 8 fluid ounces in it. You pour it out into a cup. That is not going to look like a can of soda anymore, right? The liquid has gone from the shape of a soda can into the shape of the cup. It's still the same volume, still 8 fluid ounces. It hasn't lost anything. It's just changing shape. A solid is a state of matter that has defined shape and volume. We're going to take an apple. We're looking at the apple on the screen here. It's going to be an apple all day, every day. We all know what an apple looks like. We're closing our eyes. We're thinking, okay, I got an apple in my mind. I know what it looks like. It's going to have a certain volume unless you start eating the apple. Defined volume and defined shape right there for you. For those of you who are in high school, we're going to talk more about the particles being closer together here for solids. They're tightly packed, whereas with liquids, they're able to kind of free flow and float around and do their thing. The word flow meaning something like a liquid. Also, we could talk about air being a fluid, which is different. That's gas. We're going to be talking about liquids here because we're using milk. All right, we're also making a solution today. Anything you mix in chemistry is a solution, and we do have certain protocols that we have to follow for lab safety. As you can see, I've got my nifty little lab jacket on here. I got my gloves. I also have my lab safety glasses ready to go when I'm ready to start my experiment. Do you have to wear those things today? You don't. It's food. But please get your parents' permission before you start rummaging through the kitchen and pulling out all the stuff from the cabinets. You want to make sure you have permission to do that. Okay, so solutions. We've got 2 main parts, and here's some upper level terminology for you. We've got solute and solvent. Solute is the minor component. So something like a Kool-Aid powder. You're going to make Kool-Aid, you're going to make Crystal Light, some kind of form of powdered drink mix. That solid that you put into water is your solute. We're going to be mixing that into a liquid. A solvent is typically a liquid where you put the solid in to dissolve it. Milk, water, soda, coffee, tea, any kind of liquid you can think of. I also have acetone on there, which is the fancy way to say nail polish remover, or turpentine, which is used to remove paint stains or stains from woods. The main thing at the bottom here, if we're looking at the bottom there, you see these giant bolded words that says like dissolves like. We've all been in the kitchen, or we've seen something in the kitchen where we have water and oil, and the oil's sitting on top of that water, and they never mix. No matter how much you shake it or stir it, those two things just do not mix together. That's because they have opposite polarities. We've all played with magnets. We've tried to put the north and north together, or maybe the south and south, and it just doesn't push together. It's like this invisible ball that I can't get it together. With solvents and solutes, we want them to kind of hold hands and be friends with each other. You want them to bond and kind of jam and have a little party in there. Because if they're not mixing, you don't have a solution. And for us, we want a solution to happen because I want some ice cream. I don't know about you, but I love ice cream. So let's keep going to get this ice cream going. When we're making solutions, anytime you're in the kitchen, because kitchen, making food is chemistry, it's definitely chemistry. Don't let anybody tell you otherwise. If they do, you're hurting my feelings. So we're in the kitchen, we're making food. We got to think of things to make our food. What are common things we do in the kitchen? Well, we stir. If we're making sweet tea from, scratch, we're talking tea bags and hot water and sugar and all this other stuff. You're going to agitate or stir it. Do we need to stir our solution together to make the things mix? Maybe we can just let them sit there and morph into something new on its own. Maybe we need to stir it. We also need to think about maybe temperature. Should we heat up our solution to make it dissolve faster? Should we cool it down? It just depends on what we're looking at today. We're going to be cooling it down. I got a lot of ice over here. Particle size of the solute. So we're looking at the solid. How big is it? Do I want to use big chunks like chocolate chips, or do I want to use something that's tiny and small like granulated sugar? The smaller the piece, the more surface area that you have. And surface area is anything that is open to be touched by that solvent. So more surface area, the faster it dissolves. Like dissolves like, it comes back. Do they mix well? If they're going to mix well, they're going to hold hands, they're going to be friends, they're going to be partying, they're going to make you that solution that you want. You're not going to have lemon and water sitting separate from each other. You're going to have lemonade. And if lemon and water did that, that's crazy. Let's just stop there. All right, another thing we're talking about today is going to be colligative properties. Fancy word, colligative. Sounds like you're crazy. Colligative. It's a property that depends on how much solute's sitting there. So how much solid do we have sitting in our little solution? And depending on how much we have sitting there, it's going to affect certain factors of this solution that we're looking at. And in this case, freezing point depression. I know that we've all heard at some point, especially my kids at my high school, if you put salt in water, it makes it boil faster. It doesn't. It really, really doesn't. It actually elevates the boiling point by about 2 degrees, maybe 1 degree. You're having to break the bonds of the salt in there, of the Na and the Cl, that's sodium and chlorine. You break those bonds apart. That's more energy the water has to put into actually boiling. So that's called boiling point elevation. In this case, freezing point depression, what we're going to do is we're going to take ice and add some salt to it to help the ice get colder, stay colder longer, to help make our ice cream faster. Because I don't want to sit there for 20 minutes shaking a bag of ice and ice cream, right? That's kind of crazy. I am going to challenge you at the bottom of the screen here to try something at home. You can do this own little experiment. It doesn't matter what you're using. Just make sure one thing is pure and one thing has something in it. So my 2 examples that I have at the bottom there for you are what freezes faster. Pure water, that means water with nothing in it, or salt water. You just take some water and you add some salt to it. You put those in the freezer and see what happens. Time them. Make sure you're writing down times every time you're checking to see if it's frozen in the ice box. Or if you are getting fancy, go ahead and make some Kool-Aid, Take some Kool-Aid, put it in some ice trays, put little toothpicks in there, and then try some regular ice and see which one takes longer to freeze, because at the end of that, you got some nice, tasty popsicles with that Kool-Aid. So you can look at that. We can take a second for you to write those stuff down. We're going to pause. Okay, if you guys wanted to try that and you went and did that yourself, excellent, good job. You're doing your own little chemistry at home. Any other things you want to try, make sure you get parent permission to do this, because again, yes, you are a scientist, but you got to make sure you're doing it safely. Okay, last thing we have to talk about. We're going to talk about thermodynamics, one of my favorite spots. Energy transformations. What's going on with this energy? Is it changing? Is it not changing? Is it hot? Is it cold? What is it doing? We need to know. So a couple things here. We got thermochemistry. It's the study of energy change and the changes of state. And we're definitely changing states today. We're going from a liquid to a solid, because ice cream's solid. We all know that. We also are going to talk about potential energy. If you have talked about potential energy, you know that potential energy is resting energy. That means you're zen, you're quiet, you're just sitting there. Whereas kinetic energy is crazy and everything's going on. Oh my gosh, oh my God. Well, chemical potential energy is all that stored energy inside chemical bonds. So they're just sitting there and they're waiting, they're bonded together, they're holding hands, they're like jamming, they're doing a little party, and then all of a sudden something comes in and breaks up the party. So once we have that broken up bond, we're releasing energy, and that's what we're doing here. We're going to be making ice crystals form with the salt. We're going to have the milk and the sugar interact, and we're going to make solid crystals in there, build on those sugar molecules using the fat inside the milk to help do that. We're going to break bonds. We're going to make bonds. It's going to be a crazy, crazy thing. So much to happen there. All right, last couple things. We've got heat. We've all heard heat. Oh, it's hot in here. Maybe you got somebody in your family that just sits there and goes, oh, it's so hot. So warm, oh my goodness. Well, they're feeling a little bit of heat. That's not a bad thing. It's just energy transfer. We've all felt this, with a coffee cup of hot cocoa, maybe hot apple cider, your hands get nice and toasty. That's energy transfer from the hot liquid to your hands, which are cold. Or vice versa, you've got a nice cool glass of sweet tea and your hot hands are making condensation happen on the glass because you got cool liquid, hot hands, hot goes to the cold. That's how energy flows from one point to the other, or heat goes from a high temperature to a low temperature until they reach equilibrium, which means everything is the same. If you've never experienced this, go ahead and get yourself a glass of water and hold it. You're going to feel cold hands and hot water. Promise you, watch it happen. All right. Ooh, look at those pictures. Exothermic and endothermic process. Exothermic means we're releasing heat to the surrounding areas like fireworks. We're just kind of pushing all of that heat out. And endothermic means we're pulling heat in. And today we're going to be doing an endothermic process. It's going to feel nice and cold because it's pulling all of this heat in to add energy into the system that we've got going. All right, now that's all the terminology I wanted to talk about because, I don't know about you, I'm hungry and I want to start eating some ice cream. So let's get making the ice cream. All right, we're going to do this in a Ziploc bag. You need 2 Ziploc bags. I'm going to show you the ingredients. Here they are. This is the base ingredients. I'm going to give you some time to write this down. This makes 4 serving sizes, which means you can have up to 4 friends with you making this ice cream, and you can all have your own little portion of the tasty treat. If you do not want to make that much ice cream, you can always cut this in half, which means you just take all of those measurements and you just cut it in half or divide by 2. So instead of 2 cups of milk, you have 1 cup of milk. You have a 1/4 cup of sugar, you have a teaspoon of vanilla, 5 cups of ice, and 4 tablespoons of rock salt or table salt. If you don't know what rock salt is, table salt, the salt and salt shaker, that works too. I'm going to pause for a second so you guys can get this down. Okay, and if at any time you miss something, all of these are going to have websites posted at the end that you can go look at recipes your own if you want. If you wanted to change the recipe, you wanted to add something into it, there should be, maybe not. If you wanted to add some flavorings in there, chocolate chips, sprinkles, you wanted to make mint chocolate chips, something of that nature, you can always add that in as we go. It may not be as solid as maybe your friends who made vanilla ice cream. That's just because you're adding different things in there and the chemical structures aren't setting up exactly the way they're supposed to. So what we need to do, first thing is first, we need to look at all the stuff that we need for this, and I'm going to show you guys that. Just give me 1 second. Switch over to my document camera. As you can see, I have a whisk. Ooh, ah, wow, whisk. I have my measuring tools. I've got cups here. I've got a tablespoon. I have a thing of sugar. Let me open that up for us. Okay, so I've got my sugar. I also have a medium bowl that I'm going to be using. Oh, you can't really see that too well. We'll look at that in just a second. You need 2 Ziploc bags. You need a sandwich-sized Ziploc bag. Okay. And you also need a gallon-sized Ziploc bag, which is the larger of the 2. Right now we're going to focus on making our mixture, our base ice cream, which is just vanilla flavor, just to let you guys know so that you're not going, oh my gosh, I wanted chocolate and there's no chocolate. Well, you got to add cocoa powder to that or chocolate shavings. So first things first, we're going to get 2 cups of milk. I suggest that you use whole milk. Whole milk has a higher fat content. You want that instead of something that has lower fat content. If you're somebody who needs lower fat content, it works. It just takes longer for you to mix it. So if you're somebody who needs 1% skim milk, it just takes a little bit longer for you to shake the ice to actually make the ice cream. As far as soy milk, almond milk, coconut milk, you're welcome to try it, but those are not really high in fat content, and that may not give you ice cream. So I would suggest try it this way. And if you don't want to try it, guess what? You got to watch a really cool experiment. Very easy to do at home. Maybe you're making this for somebody at your house because you want to cheer them up, give them a nice little treat at the end of a long day. Okay, so we're going to measure out 2 cups of milk. And I don't need safety glasses for this because I'm not going to be putting anything near my eyes. I'm not expecting anything to explode. That might be another program, another day where we set stuff on fire. Safely, please. Again, I'm a trained professional. I have my chemistry degree. I know what I'm doing. And if you ever have any questions, you reach out and you can ask me. My name is ashley.walls@sccpss.com. I love answering questions about chemistry all day, every day, and that's why I teach it. All right, so next thing I'm going to add to my bowl is going to be a 1/2 cup of sugar. And it doesn't have to be a full cup of sugar if you want it to be lighter on the sugar side. You want a little bit more sugar, that's fine. At a certain point, the sugar will just sit at the bottom of the bowl. That's okay. Not all of it's going to go into solution. So what we've just done is we've added our solute to our solvent. Our solvent being milk, our solute being the sugar particles. And it looks like milk in a bowl. That's all it really looks like right now. You're going to mix all this up. Just give it a nice couple good stirs. We're not trying to whip this into a whipped cream. We're just kind of just mixing it together. We're agitating it, stirring it. Ooh, oh, wow. And if you're my student, you know exactly what that's for. Okay, last thing we got to add to this mixture is a tablespoon of vanilla. It can be imitation vanilla if you want to use the pricier stuff, you want to use real vanilla extract. Ask your parents first because that stuff is expensive. It's so expensive. So imitation is just as fine. If you don't want vanilla, you want to do maybe chocolate ice cream, you can add some cocoa powder here or maybe some chocolate shavings. We give you the chocolate flavor as well. So you put that in there. You're going to give it a nice little mix there. Ooh, oh, wow. And you're thinking, how do I know it's mixed well enough? Well, I don't know. Spin it about 30 times, stir about 30 times. Just going, just stirring, doing my thing. We're still on step 1. Enjoying my life. All right, I think that's well mixed. We're going to take the small Ziploc bag. I'm going to go back to my little document camera here so we can look at what's going on. So bear with me. All right, so we got a nice little mixture here. Ooh, wow, looks like milk in a bowl. Like I told you, I wasn't lying. We're going to take the small baggie. We're going to put our mixture in there. You do not want to put all of the mixture in there because, again, this makes 4 servings. Do not try to be crazy and fit all of it into a sandwich bag. You put about half of it in there, or maybe you want to give yourself a fourth. You're not feeling as much ice cream as you thought you were. So I'm going to put about half of it in there. The other portion of the mixture here is for someone else in your group. Maybe you're doing this with your brothers and sisters or your cousins, or you're doing social distancing and you're wanting to do this virtually with a friend. Well, you can pour half of it in here and they can pour their half in theirs at their house. And that's fine, do whatever you need to do. Once it's in there, we got the milk in the bag. Ooh, oh, wow. Make sure it's nice and sealed. You really want to take some time and make sure that that thing is sealed all the way shut, because what we're about to do is we're about to shake it up. So we're going to go back to our steps here. La, la, la. Okay. Okay. We're going to put the mixture in the bag to the side. We're going to take our gallon-sized bag and we're going to add some ice. Now I know originally it says 10 cups of ice. It's just have enough ice. Ice in your freezer should be fine. That's where I got my ice. I didn't stop by the gas station and get ice or anything. I just pulled it out of my freezer. Let me load it up. Just give me 1 second. Let me use that. All right, so I've got the bottom part of the bag filled with ice. If you are a younger kid, you may want to have some adult assistance here, not because I don't think you can't handle it, just more because it's a little tricky at this point. You're going to take this ice in the bag, and you're going to add some salt. Salt from a salt shaker is fine, but what you want to do is you want to make sure that when you pour it in there, you do not, again, do not, I repeat, do not, please do not touch the ice and the salt mixture. It can harm you. I implore you, I'm asking you, do not touch the ice and salt mixture. It can hurt you. Okay, so you just want to put the salt in there. It's not going to sizzle or pop or do anything crazy, so don't worry about that. Just don't touch salt and ice together in the bag. So once it's in there, you want to leave it in there. You can let it sit for a second, kind of get acclimated. Add as much salt as you want. You want to get crazy, go crazy. Rock salt works fine too. Once you've done this, we're going to seal the little tiny baggie inside the big one. So take the smaller Ziploc bag that has your ice cream mixture, it's all liquidy, put that inside the big bag. And you're going to seal the big bag up. Seal it. You want to get all the air out, that's fine. You want to leave air in there, that's your choice. I'm talking about inside the bags here. Be very careful because, again, we're going to shake this all up. We're going to switch back to the document camera here so we can see what's going on. Move that out of the way. All right. So what I have, you can see the ice in the bag. I also have the bag mixture inside the big one. And what you're going to do at this point is just shake like crazy for about 10 minutes. You're going to be looking at the mixture on the inside, that ice cream base, to see if it starts making a solid. It's going to look like soft serve ice cream. So I'm going to pause right now and let you guys get to shaking about 5 to 10 minutes. Ready? Go. Now, if you get tired halfway through and you're just not feeling standing there and shaking ice bag for 10 minutes, throw it in your freezer. right, now I came prepared. I didn't think you wanted to watch me shake ice for 10 minutes. That's kind of crazy. And I have my ice cream here. It's a little bit more on the melted side right now, but it's definitely stiffer than liquid. So you want it to look like soft serve ice cream. It's going to be nice and look like a solid. You can add sprinkles to it at this point. If you don't want to eat it in the bag, what you want to do is kind of get the solid all over to one side, maybe push it over like a toothpaste, cut the corner off right here, and then push it into a bowl. If you don't feel comfortable doing that, have somebody at home do it for you. Okay, and again, if it's not if it's like not completely totally solid, you can still eat it. It's just milk and sugar mixed together to make ice cream. That's how they used to make ice cream back in the day. Okay, now I brought along some sprinkles so I can add those. I've also got chocolate chips because I like my ice cream being fancy. I'm kind of a fancy person. Again, once you've done all of that, you can enjoy. Make sure you clean up everything. If you're interested to see where I got my information on all of my recipes and you want to see other recipes, maybe you want to make strawberry ice cream or mint chip or chocolate and you want exact measurements, you can go to any of these websites right here, Food Network, Delish.com, or thebestideaforkids.com. Those are all very user-friendly. You can type in ice cream bags recipe or ice cream in a bag recipe on Google and you'll get a ton of results there. I hope you enjoyed it. Enjoy eating this ice cream. You worked for it and you worked hard for it. You guys have a great day and enjoy.